Welcome to the Melon channel on YouTube and welcome to Handyman Mending. Today we are repairing convection heater. Let us check what the problem is. Plug it into an AC socket, power on, and there is no activity on the control panel. In the regular Handyman episode, we would be repairing one-off items, but this time, there are two faulty heaters. They are identical. Same model, same shape. Their front are one-piece glass panels. Controls and display are on the upper right. Let us call our heaters number 1 and 2. With the front glass panel detached, all parts are now exposed for inspection. Item number 1 has a faulty heating element. Inside the aluminum fin there are two 1000 watt heating elements. Both of them are open circuit. Replacement is not readily available. On number 2, the small power transformer has an internal fault. To be exact, it is an open circuit on the secondary side. Due to the unavailable heating element, only one item from the pair can be repaired. Loose mounts and other small fixes will be corrected later during reassembly. In this episode, we will be merging the good functioning parts from two units into one working heater. The unit is turned 90 degrees counterclockwise when we unplug the top circuit board. Screws have been undone and kept somewhere outside the camera. After unplugging wiring, the circuit can be taken out. Underneath, we see the power supply and power control board evidenced by the two square blocks which are the relays. There is sign of corrosion on the printed circuit, usually related to solder flux residual on the board, contaminant and insufficient green solder resist layer. Cleaning the residual away from the board will usually stop further corrosion, increasing life substantially, but some liquid got behind the LCD glass, which needs desoldered to thoroughly clean. 2 rows of 15 solder joints each had been desoldered. The LCD glass can be detached from the board. Underneath is the backlight diffuser which spreads the light from a single light-emitting diode on the side evenly onto the display area. Since there are only 2 additional solder joints, the backlight module is also removed. The double-sided adhesive strips can be reused, provided that they are kept away from anything else stuck on them. This caution has to be exercised until reassembly. 2 sets of circuit boards are put together in this picture. The pair in the middle are fully prepared to reassemble. Dielectric conformal coating has been added to them after cleaning. Reassembly begins from the top side, or sometimes called the component side. When putting the backlight module back onto the board, let the legs of the backlight LED go through the holes on the circuit board, double-check it is squarely in position. Finally push it down to let the double-sided strips stick it in place. The LCD glass is topmost. Since there are 30 legs to insert, we take extra time to align and insert them. The printed circuit board can now be turned over to begin soldering. A piece of tissue paper is used to protect the LCD glass before flipping the board. The 4 corner pins are soldered first to fix the position, and each of these first 4 joints are reheated while applying light pressure to the glass to ensure snug fit without excessive gap. Again, we take a little bit more time to make sure these 4 initial joints position the LCD glass squarely in place. The remaining 28 joints are repetitive and relatively simple, so they will not be shown in this video. Each joint takes only 2 seconds to complete. Between each soldering joint, the tip of the soldering iron is pulled on a wet pad which is outside of the screen. The action makes sure there is no black particles being bring to the joint. Each joint will be clean and shiny. The amount of tin solder is controlled by the length of tin solder wire that we feed to the joint. In an earlier episode it was explained that we let the tip of the soldering iron touch the joint area to obtain preheating, then the tin solder wire is fed. In this episode, the same principle applied. Since all the joints links with fairly narrow copper tracks, heat retention is not a problem. In this case, a fine soldering iron tip is used for better fine control of the amount of tin solder on the joint. A large soldering iron tip will draw away larger amount of tin solder, leaving a joint that is skinnier than perceived. The printed circuit board is fully cleaned and it is ready to be refitted. The buttons on top of the springs are capacitive sensors. When our finger is near them, touch sensing will occur. The black button is a buzzer. It will make a beep sound when an input is registered. Since without the glass panel covering it the sound that it makes will be too sharp, audio is taken out from our footage. Backlight is lit, the LCD is showing information. We also checked heat is given out when the wiggly line on the LCD is shown. And so we have successfully made a new heater from 2 defective ones. Thanks for watching. Please give us a like, vote and subscribe to the Melon channel on YouTube. See you in our next video. Bye.